This is Math 1324, a question from section 3.2. And the question would read, maximize z equals 8x plus 5y, and then it would list some constraints. This one had this, and this. So let me show you what the form looks like in its entirety. So there is the whole form already filled out. We're going to go through the parts to it, but that's what it would look like. So to start with, I put the objective function right here, and I listed the constraints right here. Then I'm going to work in the constraints box. All right, for these two, the first two, I needed to reorder these so that they were in y equals form. That meant I subtracted 4x, and then I divided by -1. Okay, so I get this one. And note that this symbol changed. When you divide by a -1, the symbol flips. Okay, then I had 2x plus y is greater than or equal to 10. I subtracted the 2x. That was all I had to do with that one. These two are in fine form. So now I have 4 things that I could graph, these 4 circles. So I'm going to come over to the graph, and I'm going to graph those lines. The easiest ones are x is greater than or equal to 2 and y is less than or equal to 10. So I used my little ruler, and I knew that I was going to be over here because x is greater than or equal to 2. Well, here is x equals 2, this line right here, and I did that portion of it in black. So I knew I was to the right of that. And then y is less than or equal to 10. Well, here's y equals 10. That's my yellow line. So I know I'm over there. Then I graphed y is equal to 4x minus 14. So I had a minus 14 here. I went up 4 and over 1, and I connected those. But since I knew that that I was up here, then I'm going to be there. All right, and then this line is the y equals -2x plus 10. Went to 10, went down to over 1, that made that line. You can see that that region that is bounded by all those lines is this in here, inside. All right, so this is my feasible region. And let's see if I can, yeah, I think I'm good. All right, so now that I've got that, I want to figure out these 4 points that bound that region. And I color-coded those for a reason. So if I make this smaller again, then finding the intersections, this is where you'll do that work. So I took each set of 2 lines. So where the yellow and the green line intersect, that yellow line is y equals 10. The green one is 4x minus 14. And I wrote those two together, and I said, well, if y equals both of those, then those 2 things here have to be equal to each other. 10 has to equal that. Solve it for x. So your point then is x is 6, y is 10. Right there is one of the points. And then I looked at this one, the yellow and the black. Well, the black is x equals 2. The yellow is y equals 10. Well, that makes a point on itself. So I've got 2, 10. Then I looked at the black and the purple. Where do they intersect? Well, the black is x equals 2. The purple is the -2x plus 10. Now on this one, I had to substitute x is 2 into the y equals equation. So I had y equals -2 times 2 plus 10. Solved that down and got y equals 6. There's my third point. X is 2, y is 6. The fourth one is where the purple and the green intersect. So I've got y equals this and y equals that. Well, those 2 pieces have to be the same. So I set them on either side of the equals. I solved down and got that x was equal to 4. Make that bigger there. Then I took that 4 and plugged it into one of the y's. Y equals -2 times 4 plus 10. That gave me that y is equal to 2. So I have 4, 2. So now I have the 4 corners, the 4 corner points of this feasible region. I go back to where I had my maximize function that I started with, and I write those 4 points right there. 1, 2, 3, 4. Then I plug each of those into this 8x plus 5y, and I get a number. I did it 4 times, plugging in x was 6, y was 10, x is 2, y is 10, that sort of thing. And I'm trying to maximize, so I am looking for the largest number when I plug those in. That is my max. And it occurs when x is 6 and y is 10. So hopefully we went through the whole thing, and I think this form, which you can get under handouts, really helps you organize your information. Start out writing your function here, write your constraints here, reorganize them, graph your lines, get your feasible region, and then find where the things intersect. Sometimes color coding your lines will help you. Once you get your corner points, here, 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 put them over in this section and plug in to your objective function. If you're maximizing, you're looking for the biggest number. So I hope that will help you, and use it as you wish.